I believe this is part 4 of your exam review. It's piecewise functions. State the domain of this relation. Domain is always the x's, so we have a 6, a 3, a 7, and a 12. So our domain, I'm going to put it in order, is 3, 6, 7, and 12. Now our range is all the y values, so -4, 1, and 3. Those are already in order, and you only list them one time, so -4, 1, and 3. We don't need to list -4 twice because you only list it one time. Next up, to determine whether this relation is a function, there's just one thing you have to look at. Are there any x's that are duplicated? You have to have unique x's all the way through for it to be a function. You can't have any duplicates. So as you look here, we do have a duplicate x right here. -2 and -2. Since we have duplicate x's, this is not a function. Okay, 3. Determine whether this equation defines y as a function of x. There's basically two things you have to look out for. Y cannot have an even exponent, so it can't be y squared or y to the 4th or y to the 6th. And x and y can't be multiplied by each other. That's usually the red flags. So here, neither of those things are true, so it is a function. So if y has an even exponent, it's not. If x and y are multiplied together, it's not. Otherwise, you're good to go. Okay, number 4, we are plugging things in for x. That's what this means when you see this format right here. You plug 2 in for x. So I just replace the x with 2 using this equation up here. 2 squared is 4, plus 3 times 2 is 6. Your answer is 10. Okay, so I take this in part B and I plug it in for x. So 3a squared plus 3 times 3a. So then 3a squared is 9a squared. You have to square the 3 and the a, and then 3 times 3 is 9a. Finally, you plug x plus 3 in for x. So you get x plus 3 squared plus 3 times x plus 3. So you have to FOIL the x plus 3 squared, giving you x squared plus 6x plus 9 plus 3 times x plus 3 times 3. Combining like terms, you get x squared plus 9x plus 18. Okay, in this next one we have a piecewise function, so we have to determine, oh, I forgot to write the rest of it. One moment. X less than 1, x greater than or equal to 1. So you have to determine which one to plug it in. And to do that, you just have to look at the boundaries I just wrote in, the x less than 1, x greater than or equal to 1. Because what this is saying is that if x is less than 1, use x squared minus 3x. If x is greater than or equal to 1, use 6x plus 1. Well, -3 is less than 1, so I plug it into x squared minus 3x. And that gives me a positive 9 plus 9 for a total of 18. Now 1 is obviously equal to 1, so I use the 6x plus 1, and 6 times 1 plus 1 gives me 7. And then f of 3 is greater than or equal to 1, so you plug it in 6x plus 1. You get an answer of 19. Now number 6, you can use your calculator to help you with this one. In fact, I probably would, so let's do that. I'll move this over to the side so we can see the calculator a little better. I'm going to start with 2x plus 1. Now if you look, we're told that we are only going to be equal to 2x plus 1 where x is less than or equal to 2. Now I always want to use the 2, but then I have to use things less than or equal to 2. So I'm going to do 2, 1, 0. I can't use anything bigger than 2, but I want to make sure I use the 2. So there's 3 ordered pairs that I can graph right now. 2, 5, 1, 3, and 0, 1. 2, 5, 1, 3, and 0, 1. Now I cannot go this way because that's greater than 2. So I have to draw this arrow this way. So that gives me the 2x plus 1 portion. Now let's do the -3x plus 8. go to the table. We're only using it where x is greater than 2. So I'm going to start with 2 and then do 3 and 4. So I have the points 2, 2, 3, negative 1, and 4, negative 4. Now to be clear, because it is greater than 2 as opposed to greater than or equal to 2, I'm going to have an open circle at 2, 2. So I have an open circle at 2, 2. I also graph the points 3, negative 1, and let's see, what was that again? 4, negative 4. So I draw it that way. Okay, on number 7, a band named So's Your Face charges $200 for a show lasting up to a half an hour. So $200 is charged if your time is between 0 and half an hour. If you want to put 30 minutes, you can. That's okay. Just make sure you're consistent through the whole problem. $300 for a show lasting up to 1 hour. So if you go over a half hour or up to an hour, they charge you $300. $500 for up to 2 hours. So if you go over an hour, up to 2 hours, it's $500. Or for all day, it's going to be $1,000. Now you can do t's greater than 2. I remember when we did this the first time, a lot of people were picky and wanted it to be like this, and that's fine too. You could even do 12 hours. They probably don't do more than that. Okay, lastly, number 8. I have this plugged in the calculator in the stat plot. So you go to Stat, Edit, make sure you plug this in. It says use this data from the year 2000 and 2005. Write an equation line used to model this portion of the data. Okay, so this is by hand. If you look at the graph, we have the point 0, 426. I should have said table, not graph. And the point 5, 530. We're going to write the equation of a line just like we did back in the linear equation part. So I do y2 minus y1 over x2 minus x1 because I need the slope. That's going to give me 104 over 5, which is 20.8 for my slope. And I already have my y-intercept, so that's my b. So I'm just going to do y equals 20.8x plus 426. Y equals mx plus b. B, using the data from the year 2005 and 2009, write an equation of a line that could be used to model this portion of the data. So for part B, you're going to be using the lines 5, 530, and then 9, 670. Okay, I'm going to trust at this point you know how to write the equation of a line. So I will tell you it turns out to be y equals 35x plus 355. And then if you do the same thing with C, we're using the points 0, 426, and the point 9, 670. We get y equals 27.1x plus 426. So actually, I guess you didn't need the calculator on this. My mistake. In the year 2011, for part D, the average monthly premium was $732. Does your equation from part B or part C more closely predict this result? Well, if you plug in, let's see, 2011 is 11 years later. If you plug 11 in for x right here, you should get 740. If you plug in 11 for x right here, you should get something around 724. I think it's just over 724. So that's actually pretty darn close. C is a little better, believe it or not. But point is, sometimes splitting things up with the trend changes will help.